Hi viewers, here we will discuss about grammar. The grammar is represented with four components. One is variable and terminal, production rule and start symbol. So this set of four elements forms the grammar, and grammar is used to generate the strings. Then that set of strings forms the language. That language can be represented in the letter L, and this given grammar is used to represent the that given input string is present in the given language L or not. So the one thing is grammar is used to generate the string, and one more thing is grammar is used to represent the given string is available or not in the given grammar. And context free grammar, the context free grammar is having the rule the LHS variable produces combination of variables and terminals. So this is represented by using the alpha. So alpha contains the union of variable and terminals. So this is V union T clean closure. Clean closure in the sense the context free grammar allows epsilon also. That is the clean closure, either epsilon or any number of combination of variables and terminals. Here why it is called context free? In the LHS, the left side of A is called left context, the right side of the A is called right context. So in the LHS, that A is not having either left context or right context in the form of variable or a terminal. So in the LHS, in the context free grammar, and it should have only single variable. It should not have either terminal or variable in the right side or left side. That's why it is called context free grammar. And for example, this is given context free grammar. E derives E plus E, and another production is E derives E star E. The third production is E derives ID. So this is represented E plus E or E star E or ID. So here we are having P is three productions, and variable V is, we here capital alphabets are variables and small alphabets and operators are terminals. So here we are having only capital E, capital E, only one alphabet, capital alphabet. So variable is only one, and terminal plus 1 star 2, then ID. So three terminals are there, and start symbol is capital E. So from this we can construct the input string. For example, ID plus ID star ID. So here we can generate the string from the start symbol E. So from the start symbol E, we are taking this production. So E plus E. So in this E plus E, we can substitute any of these productions to form this string. So whenever we are substituting these productions, it should match with this input string. Then this capital E is replaces by using this second production E star E. Then this E is replaceable by the third production ID. Then this E is replaced by E derives ID, ID is replaced. Then again this E is replaced by this same production ID. So now we got ID plus ID star ID. So one thing we have to keep in mind, so we are replacing the rightmost capital E. in all the steps rightmost alphabet is replacing. So that, so it is called rightmost derivation. And this same string can be generated by another starting production. You look at this. So we are having one more production, E star E. We can consider E star E. Then the rightmost symbol is replaceable by the third production ID, and now we are having capital alphabet E here. So this is so now again we need this ID plus ID. Now star ID is derived. Now we have to derive ID plus ID. So we need plus production. So we can replace this E by this production E plus E. Again we are replacing by rightmost E. So this rightmost E replaced by this third production ID. Then this rightmost capital alphabet is replaced by ID. So here now we got this input string. So this process generates the string by using the context free grammar. Then here this same string, single string, is generated by using the different rightmost derivations. Look at here. Initially we took E plus E, but here we took E star E. So different productions we consider, but we are using the same rightmost derivation. So same rightmost derivation method. So here the single string is constructed by two different rightmost derivation methods. So if we construct like this, that is called ambiguous grammar. So like this, in leftmost derivation also, your leftmost derivation in the sense here we are replacing the leftmost symbol of the RHS. So in previous thing we replaced the rightmost symbol of the RHS. In leftmost derivation we have to take the leftmost variable in the RHS, that should be replaced. So now the given string is ID plus ID star ID. So in which we need to get ID plus ID. So already plus symbol is there. So we can replace this E by E derives ID production. Then now this is the step. So here E is, capital E is the leftmost symbol. So we need ID star ID. So for that we can substitute E derives E star E. So now this E is replaced by the second production E star E. Then now we got star also. Now using this third production, this E is replaceable by ID. Then again star is there. For this ID, this E is substituted by ID. So now we got the ID plus ID star ID. Like that, when you are taking the E star E production instead of E plus E, now again we have to take leftmost variable in the RHS. So leftmost variable in the RHS is E. So now this E, so now E star E is there. So star is there, but we need plus. So this E is replaceable by first production. This first production E derives E plus E. So that is substituted here for this E plus E. This is already existing star E. Now we got plus operator and also star operator for this string. Then this E is replaceable by ID, and this because leftmost derivation, then we are having plus E star E. Then leftmost variable is this E. Again this is replaceable by ID. Now we are having the only one variable. Then this is also replaceable by id. So now when you are looking in the leftmost derivation, we took two different productions, but we form the same string. So if we have two different leftmost derivations for the same string, then that grammar is called ambiguous grammar. Like that, when you are constructing the parse tree for the same input string, e derives e plus e first production, then this e is replaceable by id, then plus, then we need to get this id star id. For this we are taking second production e star e, then this is replaceable by respective ids. So now we will take another production e derives e star e, then here e derives e plus e. So here we have got id plus id star id. This one having again same input string two different parse trees. So this is called ambiguous grammar. So when we can say that given context free grammar is ambiguous grammar in the sense, whenever that single input string is generated by leftmost derivation or rightmost derivation or parse trees, that single string is generated by two different leftmost derivation or two different rightmost derivation or two different parse trees, then that grammar is called ambiguity grammar. And here the parser receives the tokens from lexical analyzer or scanner. So the another name of scanner is lexical analyzer. Parser receives the tokens from scanner, and it checks the syntax of each and every token. The token belongs to identifiers, operators and keywords, etc. Then using that tokens, it will construct the parse tree. So the role of parser is get the input from lexical analyzer. So it receives the tokens from lexical analyzer, and it generate the parser by using the parser. So parser is generated from the grammar and receives the tokens from lexical analyzer, then it generate the parse tree. Thank you for watching. Please subscribe this.